Hello, I'm Ms. Mask. The time of this recording is 5:45 a.m. September 17, 2025. That is 3 5s. And 5 is basically 3 for medicine. So, smoke weed every day. Today, I'm going to show you the prototype concept build of... Well, I'm going to show you the director/randomizer I made earlier in the early beginning of summer. I think it was like July or some shit, June maybe. Built over the course of about a week on and off. And actual man hours is probably closer to a day or two. And then I'm going to show you... I'll probably show you a little bit of the macro system I started on. So there's a pretty heavy disclaimer for this. This stuff here was built... mostly as like, hey, I have an idea, I wonder if I can do it. Right, like it's a concept. Now, I was hoping to build actual game systems and stuff surrounding this, but I didn't. The project is very likely dead, as it is currently. Its current concept, design, whatever you want to call it, is pretty much dead. I have touched this project not at all throughout the rest of the year. And I haven't done too much else for the last 3 years. I wasn't going to show this stuff until I had it more demonstrable. But since the randomizer is functional, and I could find no information about this kind of stuff on the internet whatsoever when I first conceived this, I have decided I'm going to show it now. So keep in mind, this is not a guide. This is not a tutorial. This is like my AI video. This is an overview. I frankly don't remember how the fuck this works myself. So, take this with like a bucket of salt. But if you're interested in the subject, I am going to show it. I'm going to show the blueprint and try to explain it to the best of what I remember. So, what is a randomizer? So, a randomizer is kind of like an... Oh, there's some fuck shit going on there. Well, my familiarity is with Dark Souls, where you can... let's see here. Where's a good spot? Let's find another video. Let's find the intro video here. So, Dark Souls randomizer, or at least the Dark Souls 3 randomizer that I played, is basically like you loot shit, it changes the position of all the items, keys, and stuff like that. The Dark Souls 1 randomizer that I played changed all the enemies as well, according to kind of like a customizable algorithm. Like, do you want bosses in this pool? Do you not want bosses in this pool? What's the ratio of bosses to normal enemies? You know, stuff like that. But basically, the core concept is it changes up the progression. So HKS introduced me to randomizers a little while ago when he was on this binge of watching like competitions between people going through Zelda randomizers. Now, I've never played Zelda, but as far as I know, it's basically the same as any other kind of like generic. You have a door, and then you have a key for that door, and your game progression path is basically built around finding those keys to open up the rest of the game, upgrade your items, you know, your weapon, armor, whatever, stuff like that. And the main thing about the randomizer, though, is you want to avoid what is called a soft lock. So a soft lock will occur if you have a door, and whatever key is required for that door, it spawns behind it. That's the main thing you want to avoid. Now, when I originally started conceiving this system, it was because I wanted to break the solvability of maps in my project. And I thought back to like my kind of like experience with this kind of stuff is mostly like Heroes of Might and Magic random map generators. So something like Dungeon Architect can do random maps, basically, but it's quite a bit of work. And I did some research into how that system works and how it's randomizer for the keys and doors and stuff, and it works. But the long of the story short is that the documentation doesn't explain any of this stuff. And I didn't really feel like trying to dig through it because I think some of it might be like native code that I don't understand. So there's just like basically no way for me to actually access like the lower level of how this is done. HKS went ahead and asked an AI chatbot, you know, the ones you normally use for cybering. And the AI chatbot explained a few like concepts of them, but that didn't really help me either. See, I'm kind of a dumbass, and when I try to visualize stuff in my head, programmatically, it usually doesn't work out too well. I'm much better at just sticking my dick into the power outlet and letting Jesus take the wheel. I'm much better at just kind of like either dismantling something I can get my hands on and figuring out how it works, or just trying to get it done. So after about like 2 days of trying to figure out how would I do this, I just couldn't put it together in my head. So I just decided just to jump into the blueprint and just do it. And in a couple of hours, I had iterated through a few ideas before I reached the point I could test it. And it started to kind of make more sense to me. And by the end of that day, I had a demonstrable system. And then at the end of the second day, I had fixed an oversight that was causing a lot of soft locking. Now, the core difference between what I wanted to do and stuff like the Dark Souls randomizers is I wanted random start locations. So in the Dark Souls randomizer, you always start off in the jail still, which means that it's very easy to determine just by the order of operations that your keys and doors won't soft lock, because you'll spawn like as an idea, you would spawn the keys and then the doors, right? You wouldn't spawn the door unless you had the key. That's kind of a logic you can do. So if you had a door that's blocking off your way to Undeadburg, the basically, you know, BC, you would make sure that you had already spawned the key before doing this. So you would basically divvy up all the spawn locations between here and then, and you would make sure that the key is spawned as a part of those spawn locations before going to the door. Or if you did the door, you could do it sectionally. You could have a segment of zone. You would say, okay, we have the jail, and we already know that the door is in a fixed location that lets you leave the jail, which means we have to make sure that this key is a part of the collection, the area that's prior to that. So you could divvy it up by rooms, by areas, however your doors are done. But a lot of that changes when you have a different spawn location, because the spawn location, especially when you have a movement system that's a little bit more accessible to the map than in Dark Souls, because in Dark Souls your jump is pretty terrible. There's not really too much of the game world that's only accessible by jumping. So you could, for example, just have something that looks for the spawn locations in the area that can be accessed by the player spawn using something like EQS or a path trace or something like that, give or take, and collect that and be like, okay, so the player can access this stuff from their spawn location. And my project is a lot different because, for one, my mobility is much higher than that in Dark Souls, and two, the mobility is very likely to increase if I continue to work on the project and iterate the character design. So I can't do something like an EQS or whatever, because EQS is two-dimensional and it won't go over spaces, right? You probably have to use like smart links or something like that, and at that point it starts to get just to be a little over-engineered for what you're trying to do anyways. So kind of really the main core of the system, and the most major drawback of it, is the fact that you kind of have to like bake the data into it, and that's what I did not really want to do. I want it to be very, very hands-free, where you just plug and play into any given map, but I couldn't really figure out a way to do that because, well, I'm not a programmer. So first thing I'm going to do is I'm going to show you how it works, because this, even though this is very conceptual and very bare bones, it does work. Which means all the soft lock prevention, the door and key spawning, and some other features are all in there, and they all behave. So I have this very, very simple, very small area set up in this map here, where we will spawn, and the key positions in some cases support randomization. I basically wanted this system to be as flexible as possible, where I could add basically anything that constitutes as a key or a door, and then their logic is governed by that entity, by that object. So this system also supports unit spawning on a weighted table right now. So it's also very primitive, but it does work. It's just there as a proof of concept, right? So some of this stuff does spawn, and it also supports a random timed invader system. I am getting a lot of frame hits right now, and I'm not really sure why. It could be due to the fact I'm running stable diffusion and some other software in the background. And I don't know, that shouldn't normally, because they're not doing anything. There's only some performance loss. So sometimes doors, could be a door here, sometimes doors won't spawn. I have it cranked up just for testing right now, so that almost all the doors will spawn. And I think I have the mobs set to always spawn as well. It's just the mob spawning stuff's pretty basic as well. I wish I knew why the performance was so awful momentarily, but let's try launching Process Explorer momentarily and see what the fuck is going on. In any event, each time you run this, you can run the possibility of running into a different location here. And the keys and the doors and whatever is necessary for them will also change. Now, the algorithm, if you wish to call it, the manner in which the keys and doors are arranged, there's only one setup for this. I don't really know how to make that kind of thing, but you could, in theory, with the way it's set up right now, add any number of things into it. I have no idea where frames are dying. Very odd. There's definitely some slowdown here. It's very possible, in fact, I've had Stable Diffusion running for a while, but it feels a little inconsistent. Oh, I'm gonna get stun locked. I can't escape. I can't escape. No, it's hard. Oh, I got away. And there is some... It seems to be kind of unrelated to what's on screen. It's just dying. Interesting. I'm going to assume it has to do with the browser, because browsers are pieces of shit. So, yeah, you can spawn over here, and you'll notice that when I spawn in here, the enemies won't spawn in here with me. Right? This room here can support a large number of doors. There's really no limit. So I'm going to explain the basic functionalities of how this system works. Now, part of the thing of it being very basic level is it's probably a little inefficient. There's very likely some optimizations that can be done for it. In its current state, it's basically just I try to get it to work, and then I'll just approach it some other time if I ever work on it again. So, the main thing that I couldn't really wrap my head around when I was first conceiving this is, how do I know what the player can access? And I really couldn't think of a way to do that without putting the data into actors that we can then access. So, the main thing with this is you have to do some setup for it. So I'll explain how it works as a overlying concept. So let's say we have a map, and the map is like this, and the map is sectioned off into different areas. So let's say in our map we have, kind of like the Arbiter map I demoed, we have some large areas, we have some inner open areas, and then we decide we need to have doors. Now, as it was, with the baked-in doors that we had normally, each door was color-coded and its respective keys were color-coded. There were multiple types of doors of the same type and multiple keys of the same type. So you basically, if you were using them for progression, you had to make sure a player could always access enough keys. In our system, each door is treated generically. So each door is just a generic door, like this. So when you look at my map inside of Unreal, you're going to see that they're all red, right? They don't have a type associated with it. That's going to be an enumerator. So the door density can be actually very high, because how many we're going to need is determined by the director itself. The director has a scaling mechanism associated with it. Just about all of its stuff in here is going to be exposed for runtime manipulation prior to activation. So you can, for example, this was for kind of like a roguelike system, where you would have 10 tiers of zones. But there would also be a depth difficulty, and the depth difficulty would then determine how many doors might spawn. What about the opposing forces? How many of those are going to spawn? It could determine things like what eligible strategies or factions can be spawned. Those may be influenced by the map. what tiers of units can spawn. It might change some of the values that are placed into it. It could change how many, events or whatever spawn. All this stuff could be factored into it. Now, not a lot of it's exposed at the moment because I'm not really fooling around with them on here, but the functionality is in there. So each door will have an enumerator associated with it that tells you what it needs, right? One of the key things that I had to figure out is how do we know where we're going to be at? What is going to be ground zero? Basically, what I determined is I have to have a custom actor or some other way of determining where the player is going to spawn. So we have the actual spawn location, and then we have a location that you're just basically going to be teleported to randomly, and then that's going to have some information on it. Now, I have made my very first debugging system in here that kind of shows what happens after that. So this is going to show all the doors and the keys and stuff that are linked to them. Kind of the linchpin of how I figured how this system needs to work is I need to do it in a two-step interval. It's not just enough to know what keys and doors are accessible to the spawn location. We need a way to compare what is linked to a door and what is inaccessible and what is accessible. So this enters the key discovery system. So I'm going to show you how this actually looks right now. So when we start the map, we go through a very simple setup here, which is we're going to get a random seed from a stream. In case we need to do some debugging, we find a seed that produces fucked values. As far as I know right now, the system cannot produce soft locks in the way it's currently configured. I haven't encountered any for a very, very long time, but it's not 100% guaranteed, right? I would like to do really, really large scale testing to know for sure, but as it is, I've never encountered it. That's what the seed's going to help us with if we do encounter it, so we can reproduce an event where it doesn't work. Then we're going to grab some actors. First of all, we're going to grab all the spawn locations of the player that exists. You could just manually do this, but like I said, I really wanted this to be as hands-free as possible, and the fact that I have to put a bunch of data into the doors and stuff like that is already kind of a lot of work depending on the density of your map. So there might be some other way I can do that. There might be some really smart way that you can put this kind of stuff together. Maybe like through an editor interface or something like that, but that's too advanced for me, so I'm not really going to worry about it. The important thing right now is that it works. All the randomization is going to be handled by this stream that we've created, obviously for testing purposes. We're going to be grabbing one of our random points, and then we are going to randomly collect stuff later on. But first of all, we need to arm ourselves with the information. We can grab all the doors in the map, and then we're going to initialize everything here. So once we have our initial start location, everything else set up, we're going to enter the director. So this is the heart of the whole system here, other than the unit spawning and stuff like that. Okay, so I'm back after an amount of days. Insomnia is a bitch. I have endless other things I'm doing. And fuck existence. 420 no scope, don't at me. Where was I with this discussion? I was about to get into talking about doors and keys. So, to cut a fairly long story short, it is currently 4:54 a.m. in the middle of September in Canada, and it is hot as fuck. Because fuck summer, fuck it all. And, that's how we're kicking off my day today, because I've got 1 hour of sleep in me, as usual. So, one of the biggest linchpins of this whole thing was trying to figure out how exactly we were going to know what keys we can access. Now, it's true, we could have a spawn location here or there that might have access to so and so many keys. And then we can link those keys to the spawn location, like I have several other things, like the positions of doors and so on, right? So let's pretend these green dots are keys, right? Now let's say these white dots, white is all right. That's going to be our player spawns, our potential player spawns. We might spawn in these locations, right? So one of the things I had a kind of a difficult time racking my head around is how do we know what we can access here? So I could link these to the player spawn, and we know that these are accessible and we can spawn them. So then if we choose to spawn a door there, then we can do a comparison that the door is connected to here. So when we have access to these keys, we can do that iteration. But then what about doors afterwards? Right? We don't have any keys over here. We have to go here. So that means the doors have to have access to the keys. But this is a problem. I could spawn here, or I could spawn down here. We don't really know which side of the door the keys are on. So this was a logic issue I had to uncover. So, in a nutshell, this became kind of a two-stage process. This is where I realized that the best way to do this was to constantly do comparisons. This is probably the most expensive part of this, other than just running a million loops, but you only do it once and probably doesn't use that much CPU time at the end of the day, especially since you're doing it part of the original load process anyways. You're going to have like shader, warm-up, and PSO and other nonsense that's going to happen when you first start the map, so have a little fade and you'll probably never notice it, even in a very, very large level. Nonetheless, this could most certainly use some degree of optimization if you're actually some kind of programmer and not a brainlet like me. So I'm going to hop into the blueprint here very briefly, and I'll show you. I'll get up to that point and I'll come back to that to kind of illustrate what it was I was doing. So when we collect all of our data, I showed you that much, and then now we're actually going to initialize the doors and the keys. So first, we're going to get what kind of doors we want. So this is, again, something we can modify in runtime that will tell us what doors we can have. These are all the doors I have currently configured. This enumerator and most of the other, actually pretty much every single other thing that ever communicates with a door or a key is done through an interface. Because what constitutes as a door or a key is intended to be super agnostic, so that you could have other kinds of mechanisms or mini games or puzzles or whatever, other kinds of things you can interact with that aren't necessarily, I have to find a key and then bump into a door to open them. But if you want something that spawns like a creature you have to kill or some structure you have to assemble a key to put into at that specific point, it opens the door. Elsewhere, what if you have a fog wall that you want to associate with some other action? All those can be set in that generic interface and they can handle themselves. But currently, in our existing doors, this is what they do. When we eventually send the interface, it's going to configure a bunch of stuff. Again, this is another thing here that I really wish I had tidied up a little bit, because I feel like there was a way I had envisioned I could do this a little bit easier than having, because we might have more than 3 materials, right? These are all going to reference some maps. And I didn't open the map because I'm fucking stupid. Those maps, there'll be the ones for the materials and then ones for the mesh, and then probably ones for sounds or something related to that too, for interaction. And kind of the issue with that is when you're placing a door on the map, you might resize it, right? And there might be different sized meshes. So one of the things I didn't really figure out, and I still don't really know, is how would I bake that data and save it on the actor without having to manually type it out. There's probably like an editor script or something like that you can do to like push a button after you've configured it and it saves the data, and then you can restore it in something like Rama's save or when the door is initialized or whatever, right? Otherwise, this is kind of what it looks like right now, right? So yellow is always piss. That's mandatory. Otherwise, this is just obviously not really done anything configured here, but if we have one set of meshes and one set of textures for the meshes are not even plugged in right now. they're not even configured. I didn't get that far. It's one of the things I wanted to have done to, you know, a solution to this. Because, you know, like this door here has been rescaled a little bit, right? So how would I save this data in an elegant manner without me having to go into some other map or array or something and type out the values? It's kind of gross, right? I don't want to have to do that. We're trying to save time, and there's already a lot of manual work in this, so I never really got that far. But otherwise, this is what it does. And if we go to the keys, you're going to find it's pretty much the same thing. When we send the interface to the key, we're also going to set up the materials and all the other stuff associated. The keys also support a random spawn location as well. As you can see, this one key I've selected has several possible spawn locations. This is just so you don't need to have a million actors for a million different key spawns. It also lets you do something cheeky, like you could have a guarantee that a key will spawn in a certain area, but it could be in any one of a number of locations. So you don't always, you know, that's just one of those things to break the solvability a little bit. Gives you a little extra tool to go by, and then we even have random orientation for it, which I was switching there to make it three-dimensional. If you have a three-dimensional key, like a floating butt plug or something like that, when you want to level your alchemy. And it's a pretty simple shit. There's some other interfaces here that we'll talk about a little bit later. I'll get back to that. So we get our types. We can have as many or as few in here as we want, but right now the system does not support dupe door types. So in Arbiter, in the map I've done most of my demo recordings on, there's multiple red doors, multiple blue doors, one green door, one gold door. And the red doors and blue doors are all optional. They unlock things like health restore statues and save points. So there's multiple keys to go with them as well. But you could take a key from one area and take it to another. This does not support that at this point. At least I've never tested it, but I'm pretty sure it won't work, because the system is built later on in the assumption that each type is unique. You could end up soft locking yourself, where it could end up spawning an extra type of key somewhere you can't access. You could spend the key and then never actually be able to access it because it's behind a door of the same type that you no longer have a key for. So there would have to be some extra work in this to properly facilitate that. Desired door count, something you can do a runtime. So then we're going to loop through however many doors we want. And we're basically going to go through the random number of all the doors in a map and just randomly activate them. So again, if you were more of a wizard, a mathematician kind of a guy, you could make some alternative logic here. Perhaps even randomize which logic is assigned. I do that for the creature spawns, although, again, there's not much in the way of logic built for them at the moment, but it's supported. Where you could do different kinds of spawning strategies. But currently, it just randomly chooses the doors. And then it sends that activation to them, randomly picking the enumerator from the ones that are available. And then it adds them to a new array. One of the things you're going to notice, and this was one of the issues I had when I first built the system, is since we're working with loops quite a lot in this, actually I think there's more loops in the director here than there is in probably the rest of my project, honestly, or at least comparable. I was constantly running the issue where I was working on arrays and stuff that I was looping through. That was causing logic issues. So, dummy moment. So, there's a lot of local variables in here just to pass data around and keep our working set sanitized. But doors to populate is basically going to contain all the doors that we need to access still. We'll be looping through that later. We track currently picked doors here, but honestly, I think this is irrelevant. There's a few things in here I just don't think I really need anymore. And I'm pretty sure that we're not using it, but I kind of left it here anyways because you never know, I might use that somewhere else. So after we've grabbed which doors we want to populate, we're going to deactivate all of them. We set them inactive. So there's a specific reason why I do it this way, and it's mostly so that the doors are not invisible in the map while I'm placing them. This is really just an editor convenience thing. I could activate them on map start or deactivate them on map start through the doors themselves, but that's kind of unnecessary. I just let the director deal with it. She's a girl boss. She can do it. And this break is surely unnecessary. I decay what I was smoking. Yeah, there's a lot of that in this, honestly. After we've done dealing with the doors, we're going to do the very first part of our two-step process, kind of the linchpin of how the system works. That's picking off the spawn point. The spawn point is ground zero. And we're going to collect all the data, the keys, the doors, and the spawn, the mob spawn collections. I'll talk about those in a little bit. The mob spawn collections are basically what's governing where the units spawn, but they have some other functionalities as well. They have an assortment of arrays assigned to them. They're also used for the macro system. It functions a little bit like StarCraft 2 bullies. And each spawn location that supports these is treated as a town. So that's for the RTS mechanics. And again, that stuff's... I'll show that stuff as well, but it's very... It's not ready to show, but again, I don't know if I'm going to be around long enough to even work on it again, given my current rate of progress. So I figured I may as well show it now. We're going to collect those and stick them into here. Now, this here is definitely not tested remotely extensively, but for each collection of doors that we can access, I treat them as a door-based zone segment. So I try to segment out the zone. This is not used in the door logic, it's used in the spawn logic. This is what's controlling the current system, where if you spawn, for example, in this room, no mobs will spawn with you. Hypothetically, if I deleted all the doors over here, and then we attached everything accordingly, this spawn location will also not spawn creatures either if we spawn in here or over here. But we'll still get spawn locations from the collection that's over there. This is used for the spawn logic in other ways as well. I mean, you can just as easily tell it to spawn creatures there, but it's also for scaling the difficulty of creatures in the level, if you want to do that, like if that's a spawn strategy you want. It's also a way of splitting up factions, because factions can be assigned to those spawn collections, and it can be based on a tendency as well. So there can even be multi-spawn acceptable, and then we can assign if it can be a nexus buildable, which means it can be used as a town. So again, that stuff is super prototype, and it's mostly just a collection of points we reference elsewhere. But we do count them effectively, and we assign these. Each segment is a struct that contains an array of these actors, because each segment can contain multiples of them. So I'll talk about the mob spawning in a little bit. But this is where we start, because ground zero is where we start. And we actually basically will emit that from our spawn data usually. We're going to grab accessible keys. And you're going to notice that the keys go into two things here. And I'll talk about this in just a moment. So doors working set trimmed is not used here. This is down there. Like I said, this is a fucking mess. I kind of don't like node-based editors, but I don't know programming, so this is the most I can get. Set delay length. I have no idea why this is here. I think because I ran into an infinite loop, which I'll talk about in a moment. There is a possibility that can happen with this. It's mostly due to it being set up incorrectly in the map itself. So we're going to do a two-step process here. And this two-step process, actually it's kind of more like a four-step process. But the first two steps is basically we're going to go through every single door that we have accessible at any given point. The initial point is our player spawn. So each of these doors that are assigned to the player spawn are going to be processed with an interface. So it's going to grab all four of these one after the other. And first of all, we're going to check to see if they need a key. And if they're a part of the doors to populate, then obviously it's a door we haven't processed yet. So this is the door we need a key for. We're going to add it to doors needing keys. And then, after we have done so, we're going to remove it from doors to populate because we do not want to tap it a second time. And then we're going to put it in process doors. And I forget the exact reason why, but we do use this later on. In the event that this was not as a part of the doors to populate, we are going to get its data. And we're eventually going to get its data anyways, but the way we're going to handle this is going to be slightly different. And that comes down to the key logic. So, for example, if this is a door that is not getting our linked spawners out of here. If it was, I think because we grab it elsewhere. Yeah, we grab it down here. So our linked keys here, we're just going to add them to accessible keys to populate if the door is not one that we want to populate. So basically, if this door is not here, but the key is assigned to it, can be populated, we're going to add them. I'm going to go to the wrong tab each and every single time because I'm a dumbass like that. And then, whatever's happened here, we're going to sequence back down here, and then we're going to get the linked mob spawners. And we're going to also do a similar discovery process. And then these are also going to be added to arrays to be processed. Key discovery used to be locked behind doors being non-necessary, which seems to have prompted possible soft locks. This was unintended behavior. So something goofy happened over there. A mob spawner is not a key. Question mark? Give me a moment here. I'm confused by that. Honestly, I'm kind of confused by that. I think that's harmless. Like, it's obviously not supposed to happen, but since I validate stuff later on, it's not an issue. Like, it's not gonna stop anything. God. If I ever work on this again, I gotta fix that stun locking. I'm pretty sure that was just like an oversight. Okay, well, I guess today had value because we fixed a very pointless, very minor thing. We check if a key is valid, I think, before we populate them. So that interface would fail on those because they don't do anything with it. And yeah, I don't fucking know, dude. Your guess is as good as mine. So basically what this is doing, to visualize it to you, is when we initially spawn, we're checking our linked actors here, which is going to grab all of our keys. So our initial spawn is going to say, hey, there's keys. We have access to these. This is step one, the beginning of the leapfrog. Okay? So keep that in mind. Very simple. And I've lost... Oh, here we go. So after we've done that, when we've completed going through the doors, basically when we initially work on the doors, we're just collecting information. We're collecting data from that door. But you'll notice that discovered keys isn't processed yet. So I go through all the doors initially, checking to see if they're doors that we need to populate or not. And then we assign them to this stuff accordingly as a result. I have no idea why I added mob spawners to the keys. That's so weird. And only if the door is not one that we need to work with do we do anything regarding the keys. We add the accessible keys to populate here. Key discovery is something we do a little later on. So after this, we're going to check to see what mob spawners got processed as a result of sorting the doors. that's when they're going to be added to another segment. So if we had mob spawners after the door that then got tapped again, then we're going to add them to here, presuming that we actually discovered any of them. Okay. Then after that, we're going to head down here to the doors needing keys. So these are the doors that were actually active that we needed to have keys. So the reason why we don't go through all the doors and do key stuff as we go along is because we want to gather as large of a surface area as possible for possible keys that we have access to. So say, for example, in this particular one, if we spawned over here, but this door did not spawn, if this door was inactive, then we would like for the keys within here to also be accessible as well. So those are going to get processed in our initial tap. Otherwise, if we do the key processing iteratively before the doors, we won't have access to these spawn points. Not initially. Which means that our key spawns are going to lose some randomness. And we're going to have like a void over here that we can go into, but there's just no reason to go over there because nothing's going to spawn in there. Okay? So that's why I do it that way. Again, you could probably do some algorithms to this to make this a little more interesting and divide it up in different ways, but that's if you're a fucking wizard. So when we find doors that do need to have keys, this is when we're going to do the next step of our iteration here. We're going to get their data, and we're going to get their linked keys. We are going to do a few things here. This is just horrendous spaghetti, and I'm not even going to try to decipher it for you. I'm just going to explain kind of what it does. So first of all, we're going to compare the keys that we currently have access to, that we know we have access to. This is the most major distinction that allows us to work, because now we can leapfrog in any direction. It's a way of comparing what we have access to what we don't have access to. And we can tell if we don't have access to it because it's not a part of the keys we've already discovered. So if stage 2, let's say, is over here, says that this is a linked key, and then these are linked keys, but we have access to these because this was inaccessible at start, then actually we have these keys already, which means we already know these keys. They're part of the processing table, but now we're aware of this one. We're aware of this one. So this one gets added to the separate discovery pool. Then when we come back later on and iterate it a second time, now this, we've discovered it. It's been added to our discovery pool, but now we know we're processing a door that also is linked to this key. And now since we've discovered it, and this gets added to the working set after we've processed our keys, we know that we'll have access to this. But this one here now gets discovered, because we don't have access to this one quite yet until this door is processed. So we leapfrog back and forth. And that is the most major way that this works. So as you can see, we're going to add these keys to the populate as we go through here. Add the keys matching our existing discovered keys before spawning, because we may be missing some. So there's kind of like a safety net here. Accessible keys are spawnable, inaccessible are discovered and get tapped when we add a second key, so that a key might be locked behind a presumably accessible door now. So it isn't just blindly doing that, it's that we iterate it, and each and every single time we process a door with a related key into it, we're going to add that door's discovered keys to our pool as well. And then when we do this, we're going to actually process these keys. And we're doing that as we're adding them to discovery, I believe. Yeah, right here. If a key is already in use, we remove it, ultimately temporarily due to rediscovery. So this is one of the most wasteful things in the system right now, is when we loop through these doors a second time because we don't know which side of the door we're working on, so on and so forth. When we process, say for example, this room here, when we add all these keys, and then we go and work on this door, because this door is linked to this key and the ones inside of here, they're all going to get reprocessed again, which means they're going to get rediscovered again, which means there is some wasted processing as a result of that. It's not going to be major by any stretch of imagination, because we're only doing the whole system a single time, but it's still a little bit of waste that if this was a super large scale thing, you'd probably want to find some way of discriminating between the sides of the doors or something like that, and then determining that side based on progression. But that could get very messy when you have a lot of doors in a single room, so I have no clue how you would do that. But yeah, once a door spawns, the door's other keys are eligible for future spawns, so all are added to accessible. And then after we're done dealing with this, we're going to clear the doors that need keys. And then we're going to go into the next step, which is we are going to tidy up some of our things here, deal some stuff with our arrays a little bit, and we're going to check to see if we actually need to do more doors. If we don't need to do any more doors, we're going to deactivate all the keys that yet remain that are inactive. Again, this is slightly wasteful too, because if we have a bunch of keys that are active, then we're calling interfaces and checking them kind of pointlessly. But otherwise, this is a very simple brute force way to do it. Just go through everything in the map that's a key and check if we've actually decided to use it. So when we turn them on by their interface, which is right here. This is using the enumerator for the door to activate the key that I showed you earlier. And if we end up adding like doors that dead end parts of the zone, we have to may do some other stuff with this, so it's like just kind of feature consideration for the future. Otherwise, if we still need more doors, then we're going to continue to process. After we have processed things, we're going to do yet another loop, which is going to collect the linked doors. So the doors that we have added to the working set trimmed, which contains the doors that we've processed at this stage, we are going to, by processed, I mean the doors that we just processed. So we're not going to do this for every single one. We're doing it for the ones that we basically just did. We're going to grab their linked doors, and we're going to add those to the process doors. And if not, if they... I see. Okay, so if we've already processed it, then we don't access it. That's what this discrimination is made. Don't add shit we already processed, because we'll just have to destroy it later. And then we just do the whole thing over again. Just kind of like I explained. So when you look at... this is the spawn actor is pointing to the doors. So these tell you... my spawn is associated to the keys and then the doors. And then you'll see that each door is assigned to every door that you would reasonably have physical access to, as well as the keys. I would like to add a little arrow animation that animates, that points at them, so you're... yeah, it's a little more obvious what you're looking at. I don't know how to do that. It was just something I threw together really quickly. So, you could reference it. Because basically what will happen is if you forget to add these linked actors, or if they reference something incorrectly, it's going to mess up the entire chain of discovery. So that's where the biggest failure point is. So now we'll talk about mob spawns. So this is even more incomplete than the first one, and it's really just bare bones. And it took me a while to get it to work at all because array length and other nonsense. So, like I said, we spawn these in segments, and who knows if I even really want to do it that way. Basically, I was trying to picture in my head a large map like Arbiter, where you can have a very large area with a very large collection of spawn points on them. Like, you know, the first major courtyard area for Arbiter that has like the underground with the pinchies in it. It has the initial weeds in and around the courtyard area. And then beyond, where kind of like little valleys are, you have dudes in the towers, and then the dudes that are where the first crow statue is and some of the dudes out in the grass area, you might have a separate spawn collection for each one of those areas that governs all the possible spawn points for them. And maybe you want to change what kind of factions can spawn there. Maybe you want Templar to be able to spawn there, right? Maybe you want to be able to change the kind of units that spawn there. So you might do it that way. I kind of would like to have a mix of a fixed system with a random system and some other stuff, but again, that was well outside my initial bricking. But anyways, that's what the system was basically allowed to do. And then we were going to be able to have ways to change the spawn strategies, which is to randomly use the locations, iterate the strength, have both sets of randoms, or just spawn everything. But there is some distinctions I wanted to do in here, which is some units are stronger than others. Not every unit is equal. We have, here, I'll pop in here and show you again really briefly. We have these cloaked sadistic weeds that made a high-level DMC3 player rage quit. And then we have these little cockroach dudes from Estelia that are very harmless and don't do anything. And their AI doesn't even work properly because it's just copy-pasted off something else. And then there is still this stalling that I'm getting. It's very weird. Very strange. I wonder if I introduced a bug of some kind, or I wonder if it has to do with my macro dudes. If they're doing something naughty, I could profile it. But anyways, obviously some of the units that spawn are not equal to others. So I wanted to do a way of making them weighted, where the stronger units may have less of a chance to spawn. And then we can modify that in runtime. Maybe we're at a high difficulty setting where they should spawn more often. Maybe the amount of them should be spawning at. So this is where we start to get into the director behavior, where I was starting to assemble all the variables I wanted to be able to have that can be modified by the depth setting and the director personality that gets picked for it. So there would be different like branches of scaling and the difficulty that affect different sets of variables. Because like the opposing forces, the invader system, we might focus heavily on invaders. So you might have more individual strong units with the, you know, individual logic that loots the map and maybe tries to open doors and fucks around with other objectives. Maybe just the raw scale, we end up with a lot of units and a lot of doors. Maybe just raw chaos, we have just more factions, different kinds of strategies can show up in weird ways. You know, some of the other tendencies and stuff like that might change, so on and so forth. So, that's all part of this. It's all part of this here. And this is pretty simple, because we are just doing a branch off of a numerator, which is coming out of the spawn strategy we've chosen for the level. I only have 2 designed here because this, again, requires some kind of algorithm nonsense that I can't even begin to approach. But we're taking those sections that got split up in the map when we were initially populating it with the doors. And then we are picking from the eligible starting factions, which will probably be zone dependent. And then we're going through these. And then we assign them to the spawn locations, and then we go through the actors. We grab their spawn points, and then we calculate. This one here is the brute force one, so we're just going through all of them and just grabbing all this shit. So in the innate faction tendency weight is, I think, what locations we might use. So the random bool with weight from stream is the major way that a chunk of this works, because that's just a brute force one where we just spawn everything. But this one here, the random and random distribution, is a little bit more complicated. Collect random map segments to spawn random actors to random points with. We should add the removed elements to a new array for future event-related processing. So there will be an event system. Think like Voices of Void, kind of. This is where we go into some stuff that took me a lot of time to get right because I'm not a programmer. If we only have 1 to 2 spawn point clusters, we'll end up emitting due to rounding down a low spawn modifier. Let's make sure we always have at least 1 we can work with. Emit spawning if there's 0, this is just a safety check. We'll do the same for the vectors. So here we have a sequence where we're going to go through all the different possible vectors because not every unit is the same. Some of them are very fat. Some of them are death fat. Some of them are obese. And some of them are normal, healthy sized. And we're going to just do all of them. Check all non-structure spawns. Structures don't exist yet, so we can't handle them. We need a way to tell the spawner to spawn fatties. And I forget what that note is for, because fatties is right here. XD. Spawn actors should never have an empty unit array, but there's a chance we have ones explicitly for structures in the future, so want to discriminate before accessing them here. So it's just collecting the vectors, grabbing the random points from it based on the runtime seeds and the variables we can use. And then we go to actually spawn the units. So there is a function here just to spawn the units. And this is where some additional calculations are made. All the unit data is contained within a faction table. Now, let's see if I can find where that faction table is. Here we go. So, this faction table, this is the struct that it uses. So it contains the enumerator that tells them what kind of faction it is. And the units are a... is that another struct? It's an array. I forget what that is. It's an array of something. Oh, it's an array of structs. There you go. That contains a float, which is a probability, and then a soft reference for the actor. This is one of the gray areas I don't know about, and I imagine anybody watching this video and picking through this utterly autistic commentary probably does know about, is when we grab a soft reference from here, I want to load them on map start. I don't want to break out of a load screen and then go into the game and then hang the game for a amount of time because we're suddenly loading an extra set of process. And I would like to just extend whatever load screen we have to cover that. The project loads insanely fast. Like, it takes like 3 to 4 seconds to start or something like that. And Arbiter is like 4 or 5 seconds, maybe, tops. It loads very fast. But it's still, you know, something I'd want to homogenize and make sure it works well. So this weighted chance is... Again, random bool with weight from stream is the way that this works. When we go to spawn the unit, we have been handed our data. We're either going to have an OnlyFans / opposing forces faction. That's for the invaders specifically. Or we're going to have a generic unit. And that is what this is for. And that is used, I think, just, yeah, right here. Just selecting between the 2 different tables of units right there. I didn't even really know about selection nodes until like years into the project. So when if I ever go back to like the player character and revise her blueprint that is like 5-6 years old right now for the most part and just has had stuff tacked onto it, there's a lot of cleanup I can do with it. And one of them is by breaking away from booleans and using enumerators to control the states because there's some weird obscure bugs that can occur. And another would be using select nodes in some specific cases to kind of tidy it up. Because it is a little bit of a clusterfuck. And yeah, this is all pretty standard stuff. The soft references is really the big thing here. So right, I tried to do async loading, but it just didn't work. So I just do this here. I tried to async load those, I couldn't really get them to behave. Actually, it took me a while to figure out what combination of things to get this to work. To turn this soft class into an actual actor class I could spawn. So there was some tomfoolery here. and it's just a random orientation. But I feel like the random orientation, we should take it. I don't. You can't rotate the vectors, can you? Yeah, you can't rotate those. So well, I'm not really sure what I would do if I wanted to have an actual rotation for them. So I will show you what the actual the things look like here, so you just have kind of an idea. And so this is the bugs that are spawning in the test map. You can see that each unit type is assigned this here. So again, this is probably a little wasteful, but we iterate through looking for these weights. And then if the weights return false, then we're just going to keep going through them until we find one that works. The problem with this is it biases our weights to the top stack. These aren't all being weighted against each other equally. We're iterating down them because we're doing it by an array, which means that we just by that chance have a high probability of pinging across these units first instead of this unit. This unit says it has a 0.3 probability, but this is actually probably a lot more like a 0.1 or less probability. It's not really that high because we're processing these first. There was a plugin or something called Fairly Balanced Loot, which was kind of like an RNG driven system for loot RNG. That seemed like it could be pretty promising for this, but it hasn't been updated in a really long time, so I have no idea if it's going to work. That was one of the things I was going to do. This was just an interim. So I wanted to have an actual dedicated RNG system that balanced these a bit more fairly and a bit more predictably. And that system may still work and may be sufficient for this. That was one of the future things I wanted to do again before I got into this. But I never got that far. So, yeah. So the final thing I want to show you before we close out this video is I hope that was descriptive enough, because I'm not planning to answer any questions or provide any support for any of this stuff. I don't. The other thing I'm going to talk about very briefly, and this is going to be very brief because we're not going to... It's like... Is it every so often that it does it? There's something on the map that does it, isn't it? I don't know. But as you can see, our dude here comes over and spawns structures. He does so without getting stuck inside of them. That's something Blizzard wasn't able to do. There you go, simple shit. He builds literal mounds of steaming shit. Pretty amazing, huh? So I was going to do, like one of the things I wanted to have was a resource harvesting. I had started work on it, but I realized it was going to take a really long time, and I didn't have that investment anymore. But I had to build the whole AI framework and everything related to for it. So this is making use of those spawn collections. And again, I'm going to be very, very brief about going through this because this is definitely not ready to show, but I'm going to show it because I don't know if I'm ever going to work on it again. So this unit here is very, very simple. I literally have nothing configured on it at all other than the AI. So the AI is still using the master that I showed in my original guide, but it has been worked on a little bit since then. Now we'll talk about the behavior tree. A worker unit that builds structures, harvests resources, evades enemies, and other such things would benefit from using a goal-oriented AI. But I could just as easily multi-thread it through use of these services. But since this was just an initial test to just try to get the construction to work at all, I did not do either of those, because that was an amount of time I wasn't willing to put into this. Instead, I focused on the individual tasks. When it came to the resource harvesting, that's when I was going to start putting in priorities and break it down into a service so that we can multi-thread some of it. But I don't do any of that. Not currently. So again, this is so prototypey that, yeah, but basically, I divide the worker tasks. I tried to envision them to be as generic as possible. So this meant more enumerators, where the tasks are actually going to be quite simple. Because what the task might be that we assign to this is going to be whatever. When the map starts and the AI activates, we're going to set our worker to be idle. The way I perceived it is that the worker task is basically going to be their overarching goal. And it is just a task, a state they maintain while they're doing other stuff. So if they're trying to hide from you, or they're caught in combat, or something like that, that doesn't necessarily change the worker task. But it will change what they do when they're no longer being occupied with some other task. So while they're roaming, they're just idle. Nothing actually happens in here currently, because this is such a prototype at the moment that I think I used either the objectives or the level blueprint to force to give them a objective. And when they do get, in this particular case, the worker task is equal to construct building, and where unit state is set to idle, I can enable this, but they'll just run forever because their perception's not set up properly. Then we can actually do the unit task. And this is going to contain references to another number of variables here. For example, our actual worker task will reference the worker task variable. We'll have reference to the mineral goal. One of the things I wasn't sure about the minerals, because I wanted to have collections of minerals, is A, should they be destructible? B, should there only be individual mineral structures? C, should we be looking at like StarCraft where you have mineral fields? How would those be done? Individual actors, one actor I tried to have one actor containing multiple sub-actors, but that was impossible. That was kind of a weird limitation, but okay. Construction goal type, target location. And, is that interesting? Why is that construction goal type? Or target location, rather. Hang on, let me pop into this for a second. I want to see something. We're discovering some odd behavior. Construction goal type is Nexus. We just don't use that, I guess. Interesting. I wonder what that slowdown I was getting was. I didn't get that last time. I feel like something broke in the map with 5.6. Huh. I don't know. This is really messy, but we'll go through it. We'll go through it. So, force reset. We'll, I have no idea. This is like looking at Blizzard shit at the moment, where it's like nothing makes any sense because it wasn't labeled properly, because I never put it past. Break construction fudge pack struct. Good shit, good shit, good shit. Alright. I'm not going to be able to explain this very easily. I hope you can make more sense of it than I do, because I have not looked at this for so long. And I actually kind of struggled with this, because getting them to actually iterate this stuff was surprisingly difficult because there was some kind of oversight. But I tried to... If we do a full reset, we grab our AI controller, we get the construction goal, we make sure it's valid, we check to see if that goal has a nexus, and target was destroyed. Worker task. I forget why I do this. I think force reset is special behavior I probably shouldn't even try to talk about because I don't remember what it was. Basically, I was trying to boilerplate this to make sure that if the core structure of a town was destroyed, that it disassociated the workers from it, or otherwise told them that it was destroyed, so it could be repaired. Because if you're not familiar with Brood War is really, really, really bad. I mean, StarCraft 2 and everything like that's pretty bad too, but Brood War is really bad. Warcraft 3 is really bad. For if you destroy the AI's main town, the whole thing shuts down. If you destroy the Nexus or the Hatchery or whatever for their expansions, shit just breaks. Like, they're just not really capable of like cleaning up after this, and they're not really capable of like rebuilding. So I'll always keep that stuff in mind when I started to build my RTS AI, is like, they need to know when that main structure is destroyed that governs the town. And that's kind of what this was. But this has never been tested. I've never tested this, so try to ignore that. But that's like the fledgling foundations for this. And we have no force reset on. Then this is where we actually start to do the things here. And again, resource harvesting was never done. Construct building is going to populate the goal data and then approach the goal. So my way of doing this, my way of trying to make this as flexible as possible, was to, in anything that could be a worker task, harvesting resources, constructing buildings, possibly like repairing buildings, hiding inside of a base, or whatever, you know, anything related to their abilities as a worker would be a worker goal, worker task. So we can just assign them this generic enumerator that divides what that is. We can be idle. The worker is idle. Any other actions can take precedent as they want, or they can change based on if they're idle. For example, if the worker is going to harvest resources, but it encounters enemies and it wants to hide and run, it maybe should go back to its base, or it should look for a nearby base. If the worker is idle, if it's not doing anything and it's being attacked, maybe it could find a generic place to hide. Maybe it's not assigned to a base. Whereas if we are harvesting resources and we're being attacked, then we can just run back home. Or we can try to hide in a generic location. But if we already have our minerals, we don't want to go hide in a random location. We just want to run back to base, purely. If we're constructing and our base is being attacked, we may not want to hang out at the base at all, or we may want to find defensive structures we can hide behind, right? So, like, whatever behavior we can do based on this enumerator, it's very, very powerful. So when we populate the goal data, we're going to grab the current construction goal from the AI controller. So kind of the part of the problem I have with the way that the behavior tree is set up in Unreal is the behavior tree cannot store certain kinds of data. So I can't, like, when you go to the buck board and you try to make new keys, those keys, you can assign them to certain kinds of variables off of the key type here, but you can't, like, give them structs in a lot of cases. Like, I tried to use structs, but it didn't work. And I forget what the reason why the structs didn't work. Like, it didn't populate them or something like that. And I remember reading on their forum that it was a shit show. So, like, the shit was just, and you can't, like, put arrays in it either. And I don't know if that ever was fixed or not in 5.6 or whatever, but I know that I had problems with this explicitly, that I could not put this kind of data in there. And it's kind of like I was talking about my AI overview. Some functions are just better done in the AI controller. So this is one of those things where I go into the AI controller and I just store that data in there as opposed to the blackboard. It just turned out to be better. And this struct contains a lot of the data that we would need for the structures. It's the kind of structure task that we want. What are we going to build, right? How large is that? That's going to use for placement for our workers' distance from it. The location of where that objective is going to get populated into the goal location. What kind of structure it is. This can be a nexus, which would be a core structure, something that you return resources to. It can be a spawner, like, you know, barracks, a factory, something like that. It can be a small structure, a major structure, a massive structure, but those are going to be used to divvy up based on the spawn locations, because we could build some very large things. We don't want to try to put those in areas that are going to be confined. So that's where the bully mechanism comes from. So we'll have to bake those locations into it too. I tried to use EQS and random location for that. It's a good way to make your project stall like fucking crazy. So I just settled on having baked locations for those. That's where the spawn location collections come in. But there will be small generic structures, little towers, landmines, stuff like that, that's small enough I can just use EQS to keep them away from other structures, but still something we don't necessarily place 1,000 different locations for. So those are obviously not implemented, but that's where this would be. And then owning Nexus. This is so that when we are building any of these other non-Nexus structures, we assign them to the town. This data will be assigned. They'll be assigned to the town. So then if that Nexus is destroyed, those structures will have to be accounted for. But since I believe that those structures are assigned to the spawn collection, yeah, here we are, assigned owning spawn collection. Then when a Nexus is rebuilt there, and if your faction owns that stuff, any vestigial structures that are still left behind, like towers or whatever, will get reassigned to that Nexus. And that's also to ensure that those locations remain free. Vectors do not really have a concept of who owns them or if something is actually occupying them, so there's some manipulation for that too that has to be very carefully thought out. And that is that was something I've been very concerned about when I was building this, is how do I make sure that we do not re-attempt to use a vector that we've already used that's currently occupied? How do we know to clear that and re-add that location? And I think the way I do it's a little hacky at the moment. And then when we go to actually construct the building right here, that's where we just collect our data, right? Go location, get it as a vector, random orientation. And then once we have built that structure, we're going to grab the Nexus component if they have it. If we don't have it, then we are going to assign it to the Nexus that owns it. We're going to assume that if they do not have the component that does the Nexus management, that they're belonging to one. So that's a failure point, but it's basically build your assets in a non-dumb way, hopefully, and probably add some kind of error reporting down here in case I oversee something. And then cast to spawn collection after that. Again, we're going to assign that to the spawn collection that was the Nexus that owns it, stuff like that. We're also going to set the instigator and things like that too, because those are used in some cases, and set their owner and things like that. Then after that, we'll set the worker to idle. So there's a lot of problems that could happen in here, like if the worker is stunned or interrupted, because right now there's no concept of construction time, right? Like if we pop into here and start, they're just going to appear. This is something I need to build if I get into this again, not just for structures but for units, is a concept of I wish I knew what that slowdown was. I have no idea. It's definitely something in the map. I'm gonna have to profile it if I work on this again. It definitely wasn't there before. Very strange. When in construction is handled, then yeah. What happens if all this stuff is interrupted? You gotta have some. There's a bunch of different stuff that goes into it. Like I said, I didn't really want to show this in such an incomplete state, but I figured it's better to show something rather than nothing, and just kind of like show you where I was at. I usually release an annual demo video for this project, or at least I tried to, but there won't be one this year, so this is the closest we're going to get. Other than the structure stuff that I wanted to get done anyways, I have no idea if I was ever even going to use a director for anything. And I still don't know. I do not get those slowdowns inside of here. Very strange. Yeah, I'm really tired because I have horrible insomnia, so I'm gonna just call it there. I realize it's not the most exhaustive overview. That's why I give you so many disclaimers. But it is what it is. Smoke weed every day. Canada is a failed state.